Welcome to the Cocoa Bananas Comedy Hour, starring Cocoa Bananas. Hello, 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 hi, hi. Oh, there she is. All right, here's what I got for you. Here's what I got for you today. We're going to have someone take an exam with commentary. Ah, how great is that? Here we go. Let's meet the contestants. Taking the exam, Samwise Gamgee, you may remember him from Lord of the Rings. And the commentary provided by Grishnak of the Uruk Hai. All right, here we go. Well, Mr. Grishnak, can I ask you for help?
My job is to flunk the halfling. Do it yourself.
Oh, well. All right, here's one derivative to do. Y prime equals, x times sine x. I'm going to do the product rule. The derivative of x is 1, and it's times sine x plus x cosine x. Well, Mr. Grishnak, is that all right?
Yeah, it's fine. I wouldn't have written the 1.
Next up. Oh, this is a weird derivative. I'm going to write y prime. But what do I do here? I think it's the fundamental theorem of integral calculus part 1. Sine 9x cosine 9x. I think I'm done.
Ah! Fool! Fool of a halfling! You forgot the chain rule!
You have to multiply by the derivative of 9x. Throw a 9 in front. Or you can throw it inside, but you need a 9. Now that is correct. Next up. Y prime equals. Oh, somebody gave me the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. I think we can simplify. The top becomes 6x plus 4 minus 6x. Is it going to be a plus 9 or a minus 9? What do we got here? Has to be a plus 9. And now we've got 6x minus 6x, which is 0. 4 minus 9 is negative 5. I think I'm going to get this one right, Mr. Grishnak. If I can remember how to make a 5. Oh, there's nothing else up there, just negative 5. All over the bottom square. What do you think?
I've seen neater jobs.
Next up. Ooh. Just term by term. Nothing tricky here. 1 minus 2x plus 3x squared. Nothing weird there. No strange rules. All right, moving on. Perform the integrations. This is just the integral 0 to 1, and
This is an easy integral, isn't it? Isn't it just x plus 1 to the second over 2? I did the chain rule. Is that okay? It is okay because the derivative of the inside is 1. Still have to evaluate. So the final answer is going to be, put a 1 in there. That's 2 squared is 4. 4 divided by 2 is 2. Minus, now put in the 0. 1 squared is 1 over 2. That's 2 minus 1/2. So the final answer is 3/2. There we go. That's okay. Next one. Well, this is chain rule too. If I want it to be, I could multiply this out, but I'm not going to do that. This is equal to, I need a 2 on the 2. I need a 2x right here because that's the derivative of the inside. So I'm going to have a 1/2 out front. Integral 2. And all this other stuff the same. Just pretend I wrote it in there. Now I'm ready for the chain rule, which will be chunk to a power, the 1 higher power, inside unchanged, over the new power, plus c. Well, Mr. Grishnak, I'm feeling pretty good about that one. Fool of a hobbit! You fool, you forgot your own 1/2. Oh, yeah. I'll just stick that out here. I'll make this an 8. What do you think of that? Oh, it looks so good. And that's fine. That's fine. It's a fine answer. Begging your pardon, Mr. Grishnak, what do you like to do on a day off? Well, I like to get my best girl and pack a picnic lunch, go out in the woods, and find the halflings! Well, I reckon if I was lost in the woods, I'd want you to find me, Mr. Grishnak. Well, let me focus up on this exam here. An American ferret rancher? Oh, that's my dream job. Needs a rectangular region broken into these 2. I misspelled 2. These 2 smaller regions. 180 feet fence. Find x and y to maximize area. Okay. Well, I can see the area. It's 4 times y plus x times y. Can't take the derivative of that, though. I need to use that 180. And that's equal to 4 plus 4 plus y plus y plus y plus x plus x. So that's 3y plus 2x plus 8. And I need to substitute for, let's say, for x. So I'm going to have 2x equals 180 minus 3y minus 8. Divide everybody by 2. And I've got a substitution for x. And that's going to be 90 minus 3/2 y minus 4. Well, 90 minus 4 is 86. So it's 86 minus 3/2 y. All right, I'm ready. I'm going to put this right in for that x right there. So I have area equals 4y plus quantity 86 minus 3/2 y quantity times y. So a prime equals 4 plus. Well, this is 86y. The derivative of 86y with respect to y is 86. This was 3/2 y squared. The derivative will be 3y. What do you think of that, Mr. Grishnak? You fool of a hobbit. You lost the minus sign. And that will screw it up royally. You'll get a negative y. Does that make any sense? Oh, begging your pardon, Mr. Grishnak. Put that minus in there. All right. So back to 90. 90, if you set this equal to 0, 90 equals 3y. Y equals 30. And if y equals 30, let's see, how about there? Y equals 30. 30 divided by 2 is 15. 15 times 3 is 45. X equals 45. These have to be right. They're such nice numbers. Now, find x and y which give maximum area. Well, I'm done. I don't have to actually find the max area. It didn't ask for the area. But if I needed the area, it would be 49 times 30. Next up, I'm having a great time with this exam. Finish this definition of the derivative any way I can. Any way I can. Any way I can. Well, here's f of x, 9x squared. And this is the definition of the derivative. So this answer is going to be 18x. Next problem. I'm crushing this. This exam's easy. All right. Find the volume of the solid generated when the region bounded by y equals x cubed. All right. Y equals 0 and x equals 1. So here's x equals 1. That's a vertical line. X cubed comes up like that. And they intersect at 1, 1. Y equals 0 is the x-axis. So it's this region, and it's rotated around the x-axis. Oh, how nice. So it's just a trumpet. Just the bell of a trumpet. Here's a disk. The radius goes right up to the curve. R equals y, but that also is equal to x cubed. And because my disk is perpendicular to the x-axis, I have to have the volume is equal to pi integral r squared, which would be x to the third squared, and it's got to be a dx. And this goes from 0 to 1. What do you think, Mr. Grishnak? Oh, you hobbit, you're pretty smart. Look at all this space you didn't use. Yeah, I can use this space here to finish the problem. The volume equals pi integral. That's x to the 6th dx. Still haven't integrated yet. And now I'm going to get pi x to the 7th over 7 evaluated from 0 to 1. So my answer is just pi over 7. I'm feeling good. Wait until you try this next one, you stupid hobbit. I reckon I'm not too stupid, Mr. Grishnak. I'm crushing this exam. Find the area between the curve y equals x cubed, x equals 0, and y equals 8. Well, here's y equals 8. Here's x cubed. They want me to find this area. Oh, I know how to do this. I know how to do this. I know what to do. It's top curve minus bottom curve. Integral. Top curve is 8. Bottom curve is x cubed. It's a dx. Because I'm integrating this way. And all I have to do is go from 0 to the place where these intersect. And it looks like it's at 2. Let me just make sure. 2 cubed is 8. Yes. That spot is 2 comma 8. Perfect. I integrate from 0 to 2 because that's what x does. I don't use the 8. The 8 is a y number. I use 0 to 2. Well, this is an integral. I can do this integral. This comes out to be 8x minus x to the 4th over 4 evaluated from 0 to 2. And since both of these have x in them, when I put in that x equals 0, that's going to vanish. So I only have to do the 2. 16 minus 2 times 4. Well, these two 4's cancel, actually. 16 minus 2. 16 minus 2 is 14. That area is 14. Well, let's see. It's 8 units up and 2 units over. This full area would be 16. And this is a pretty big piece of it. So that area being 14, I can take it. There's just this little skinny fin over here of area missing. I think that's an okay answer. What do you think, Mr. Grishnak? Oh, you drive me crazy, you Hobbit. You're getting everything right. Oh, look at that. It's the last page of the exam, Mr. Grishnak. I'm doing great. Well, got to take the derivative. And that's going to be 3x squared minus 27. And if I set that equal to 0, I can divide by 3. X squared minus 9 equals 0. X equals plus or minus 3. All right, let's finish it. Let's finish it. Halfling, what is this? What is this object? It's my calculator, Mr. Grishnak. I set my window up to 200 by 25s, and I found a bump at -3, and I found a bump at 3. I'm ready to graph. Just got to find the y coordinates, and I'm all set. And there's the rest. Typical, 108 for the max, halfway up for the inflection point. Everything works, and it looks like the picture on my calculator. And the last question is kind of a joke question. I wouldn't do this on every exam. I must have liked this bunch. So if you know the fundamental theorem of numerical calculus part 1 and 2, at least you're prepared. I can't ask you guys that because I know you can just look in your book. All right, hope you enjoyed the show.